Section 7, momentum equations. So we'll write the equations into the box. The first equation is just momentum, and the proper symbol for momentum is little p, equals mass times velocity. And the separates only equation that's given to you on the data sheet is force equals change in momentum divided by time. And the law of conservation of momentum is total momentum before a collision or explosion is equal to the total momentum after the collision or explosion in a closed system, and that means no resultant force on it. So what does each letter stand for? P is momentum, and the units of momentum are kilograms meters per second. M is mass in kilograms. V is velocity, and it's important that you remember it's velocity, not speed, because momentum is a vector quantity and velocity is a vector quantity, and it's in meters per second. Force is in newtons, which is F, and time, T, is in seconds. So, first set of questions. Calculate the momentum of a car of mass 2000 kilograms travelling at 35 metres per second. So we're finding the momentum, underline the mass, underline the velocity, and you just multiply them together. 2000 times 35, which is 70,000 kilograms metres per second. Question 2, same thing, finding the momentum, underline the mass, underline the velocity, and so you're doing 0.15 times 0.08, and that comes to 0.0120. Question 4. So you're writing down the momentum equation. Momentum equals mass times velocity, and this time, what is the speed of a bike if it has a momentum of 1800 kilogram meters per second and a mass of 120 kilograms? So you put your numbers in, you're given the momentum, that is equal to 120 times the velocity, and so you do 1800 divided by 120, and that gives you 15 meters per second. Okay, so this one you've got a diagram. Write down the equation. Momentum equals mass times velocity. So you're given A has got a mass of 1,200 grams. You should immediately think, oh, I've got to convert that to kilograms, and you're given the speed in the diagram. So momentum equals mass times velocity, so you're going to do 1.2 kilograms times 4, which is 4.8. Okay, standard stroke higher questions. So you're given some information in the diagram. Ball B has got the same mass as A, 1200 grams, and is stationary. So what you can do is write out the mass above each ball. You don't write 1200, you convert that into kilograms, and they've both got a mass of 1.2 kilograms. So don't be afraid of writing extra information on the question to help you. And you're given that ball A starts moving with 4 meters per second, and after the collision ball A moves at a lower velocity of 1 meters per second, and you've got to find the new velocity of ball A. So the way to do this is to write out the law of conservation of momentum. So momentum before equals the momentum after the collision. So what is the total momentum before? Ball B is stationary, so it's got 0 momentum. So before the collision, it's just the momentum of A. which is the mass times the velocity of A. So it's 1.2 times 4. That is the momentum before. But after, you've got the momentum of ball A plus the momentum of ball B. So you know that ball A, after the collision, moves at 1 meters per second. So the momentum of ball A after the collision is 1.2, its mass, times its new velocity. So that's the momentum of A, plus the momentum of B, which is 1.2, its mass, multiplied by its new velocity, which we'll call V, that we don't know. So then you just work out what this is. So 1.2 times 4 is 4.8. 1.2 times 1 is 1.2, plus, and you can leave your brackets in, 1.2 times V. So you've got to get this part of the equation by itself. That's added to that, so you want to take 1.2 off both sides. So 4.8 minus 1.2 is going to equal 1.2 times V. 4.8 minus 1.2 is 3.6. So 3.6 equals 1.2 times V. So to find V, you do 3.6 divided by 1.2, and that's going to give you V, and when you work that out, it's 3 meters per second. Okay, next question. Okay, so this is similar to the previous question. The only thing is that in this collision, when they collide into each other, they actually stick together on impact. And the question is, calculate the speed of the combined trucks. So once they've stuck together, what's their combined velocity after the collision? So you do it in the same way. You always write out momentum before collision equals momentum after. So what's the momentum before the collision? It's the mass of truck A times the velocity of truck A plus the mass of truck B times the velocity of truck B. So use your brackets to help you. So it's 1,500, that's the mass of A, multiplied by 8, which is the velocity of truck A, plus 2,000, the mass of B, multiplied by 1, which is velocity of B. And then the momentum after is going to be the total mass of A and B added together, multiplied by the velocity that you're trying to find out. So 1,500 plus 2,000 is a mass of 3,500, multiplied by the velocity that you're trying to find out. So work out what the left hand side is. That times that is 12,000, plus 2,000 times 1 is 2,000, equals 3,500 times the velocity. So add those two together and you get 14,000 equals 3,500 times V. So to get V, you divide both sides by 3,500, and when you work that out, you get an answer of 4 meters per second. Okay, so question 8 and 9 are separates only questions because it involves the separates only momentum equation. So a car being driven at 9 meters per second collides with the back of a stationary lorry. The car slows down and stops in 0.2 seconds. Total mass of the car and driver 1,200 kilograms. You've got to calculate the average force exerted by the lorry on the car during the collision. So you're going to use the equation force equals change in momentum over time. In symbols, that is mass times change in velocity over time. And so you put your numbers in. Your mass is 1,200 multiplied by the change in velocity is going to be 9 because it starts at 9 and it ends up at 0. So the change in velocity is 9 divided by the time 0.20, and so you work that out, 54,000, and the unit of force is newtons. Okay, so for this question, the mass you need to know the mass of the ball, and it was missing off this question, so your teacher needs to tell you that the mass is 250 grams. So the ball reaches the batsman, it's travelling at 30 metres per second. The batsman strikes the ball, moves off at 30 metres per second in the opposite direction. That's important. And you can see that they're in the opposite direction because you've got plus 30 and minus 30. So you're going to use the same equation. Force equals change in momentum over time. Okay, so the ball is 250 grams, which is 0.25 kilograms. And the change in velocity is 60 because it's going in 30 in one direction, 30 in the other direction, so the actual change in velocity is 60 divided by the time, which is 0.001, and so that comes to 15,000, and the units newtons.